Hi, in today's video I'm going to be covering ffmpeg scene detection. What this will allow us to do is analyse a video and find all the changes in the video and create a text file with a list of those timecodes. We can then use that to automatically chop up that video into separate scenes. What I'm going to do is take you through a series of scripts I've written that will allow us to analyse the video, create a series of cut points, and then convert those into a format ffmpeg can use to then cut the video into sections. So first of all, this is the ffmpeg filters page that actually contains the information we're going to use about how we can sort of select scenes based on the difference between them. So what I'm going to do is come across to the desktop, and I've created a directory called scene detection, and in that I've got Big Buck Bunny. And what I'm going to do is I'm going to run the scene detection script with a threshold which we can set from 0.1 to 0.9 to analyze the video. And that threshold is basically the difference between the scenes. So what I'm going to do is run scene detect -h to display the help, which is always helpful. And basically, let's put that back up here so you can see at the top. The script accepts an input, which is going to be the video. The -t option is the threshold, and it's got a default threshold of 0.3 if you don't specify a threshold. And also a format where you can specify the output in seconds, because ffmpeg has two timecode formats, seconds and sexagesimal, I think it's pronounced, but I always think of it as sexydecimal. Which is hours, minutes, and seconds. So the reason this is important is because we actually have to do some maths to calculate the duration of the clips. So what I'm going to do is actually run the script with the default options and analyze the video. So scene detect -i Big Buck Bunny. And what we're doing is, excuse me, I'm going to switch across and actually show you the script while this is executing. So what we've got here is the usage, so that when you run the script with -h, it displays the usage. We've got some error messages. We check the arguments passed to the script, and then we've got a regular expression for the threshold and the format. So when you specify the -t option, it's going to check that it's a number from 0.1 to 0.9. And then what we have down here is the get ops, and what this allows us to do is analyze the options that are passed on the command line to the script, like -i for the file, -f for the output format, -t for the threshold, -h for the help, -o for the output file name. So what we've got down here is some variables. So what we do first of all is we get the input file's file name without a path, so we get the actual file name. We're setting an output default file name, which is going to be the input name -detection and the date, and we set a default threshold. Now what we've got down here is two functions, and I think the script has actually finished running. Let me just come across. Yes, it's finished running, but I'm just going to briefly go through this. What we have to do is, let's say we've got two different kind of formats. We're using ffprobe to analyze the video, and what we can do with ffprobe is actually specify the if I come down here, first of all, what we do is we actually get the duration of the video, which is important, as I'll get to later on. If the video doesn't have a duration, there's obviously something wrong, so we're going to exit. Maybe you're giving it the wrong file or something. But this detection block of code, what this does is basically it will show the PTS time, and what that is the actual time code of the scene change. Yeah. And what it's then going to do is it's basically going to output that as a text file later on. So instead of using ffmpeg, which a lot of people do, and then they use grep and sed to extract the time code, that's just the wrong way to do it. Use ffmpeg, and you can actually specify the PTS time and get the time code without any sed or grep. So there's the two functions for the seconds and the sexadecimal format. And then basically what we do at the bottom is we detect if you've used the seconds format or not, and then we run the correct function. And then what we do down here is we're actually using awk, and what we have to do is prepend the start of the video and the duration of the video to the cut file, because the cut points are basically, the first cut point is going to be at the end of the first scene, and the last cut point is going to be the beginning of the last scene. So what you need to do is prepend 0 to the beginning, so you can create the first clip, and then you need to create append the duration to the end of the cut list so that you've got the last clip. So after explaining how that works, what I'm going to do is switch back to the desktop, and what you'll see here is we've got this big buck bunny detection and the time.txt file. So what I'm going to do is I'll open that with Emacs, and basically what you'll see here is we have a list of cut points in sexadecimal format, or sexadecimal format of hours, minutes and seconds and milliseconds, and these are all the cut points that are being detected in the video, the changes in the scenes. So as I said, we have to prepend the start point and append the end point, which is the duration, so that this is going to be the first clip. So the first clip, the detection is 11 seconds, and then the next one is 15 seconds. So what we actually have to do is ffmpeg doesn't accept a start and end point for a clip. It accepts a start and a duration. So what we have to do is actually subtract second line from the first line to get the duration. So the duration of the first clip is going to be 11 seconds. Right, the next clip starts at 11 seconds to 15 seconds. So that's going to be like a 4-second clip. So basically what we have to do is actually figure out a way to go through this file and then take all these time codes and then basically subtract the second line from the first line to give us the duration. What we need to do is we have to have the start point, then we have to subtract the second line from the first line to get the duration. So that's how you can create the scene detection file. And again, you can specify, as you see here, I can specify a threshold. By default it's 0.3, you can specify 0.4, 0.5, whatever. But what we're going to do now is we've got all these edit points, but we can't visualize what those edit points refer to in the video. They're just time codes. So how do we see where those edit points are? And the way we do that is by creating an image for each of the cut points in that file. So what I've done is created another script called scene image. I can spell right, -h, let me just put that up there, -h. And what this does is this accepts an input, which is going to be the video file, and a cut file, which is the scene detection file we just created. Let me just wet me whistle with some tea. So now what we're going to do is going to run this scene images file, script rather, against that detection file we just created. And what it's going to do is it's going to go through and seek through the video at all those points and then create an image. I'm going to run scene image -i big buck bunny, and what I'm going to actually do is rename this file here. So I'm just going to rename this detection, so it's easier for me to type detection.txt, and it will just make it easier explaining stuff. So we've got the big buck bunny video file and the detection file we just created. So we're going to run scene image, and again -h for the help. we give it the input file, the video, and the cut file. So scene image, -i, big butt bunny, and then -c, and the detection file. And as you can see, what it's doing now is it's going through the video and it's basically going through all those cut points and creating a frame. So what I'm going to do is come across and show you the script. So this is scene image. Same deal, we've got the usage. I'll skip through all the same stuff before. We've got the get ops, the variables where we get the file name, and then what we've got down here is this is the code. We've got a while loop and an extract function. So what I'm going to do is go through the while loop first of all. So what we've done is we've created a counter outside the while loop and set that to 1. And then what we're doing is we're saying while ifs read, and we're going to set that variable to seconds. So each line in that file is going to be set to the seconds variable. Then what we do is we run the extract function and we increment the count. Now what we do is we come up to this extract function here. What we do up here, first of all, is we've got the output name, which is going to be the input file name -count. So it's going to be like count. Each file is going to be created incrementally with a different file name, like 1, 2, 3, 4. Okay, so this is the important bit. For this to work, to get ffmpeg working with a while loop, what you have to do is you have to specify this option -no sdin. What that does is that prevents ffmpeg from trying to use the read command's output, because otherwise if you don't have this special line of code, what will happen is you run the while loop and it's only going to create one file. So that's the secret sauce of getting a while loop to work with ffmpeg, this no sdin option. We then hide the banner and the stats, and then what we're doing is we're taking this seconds option here, this variable, this seconds option, this variable here, corresponds to this section, this seconds variable in the while loop. So this seconds variable in the while loop is going to be equal to the line that it's reading. It's then going to pass that line, that variable, into ffmpeg. Yeah, so we can basically loop over the thing, say each line corresponds to a second, and then pass that into this function. Then what it does is it takes the input file and it creates the image, and we set v-frames 1, so it just creates one image at a time. Then we've got the output. So again, what we're doing is we've got the while loop with the counter outside it. We set each line to correspond to the seconds variable. We run the extract function and then we increment the count. We've got the out file name there. We've got the no sdin, and basically it's just going to keep looping over each line in that text file, seeking to the second, and then taking an image. So that's how that script works. So that should have finished now. So as you can see there, we've got all the files incrementally created, and you can see in the terminal it's actually going to list them like 100. It's going to list them like this. Whereas in your file manager, I come across the files, desktop, scene detection. You'll see they're actually listed properly. So we got Big Butt Bunny 1, 2, 3, 4. The reason why I've used a count because I couldn't actually pass the seconds in. That was my first thought, is to append the seconds to the file name, but you can't, because you can't get the variable name because we're using the no sdin in ffmpeg. So if I run skiv-t-i, you can see what we've got there is we've got all the images. We can actually see where the points are that have been extracted. So you've actually got a full visual list of all the scene changes in the video. Okay, so we can now see what's been cut up and where it's going to cut it up. So the next step that we actually need to do is what I'm going to do is I'm going to remove all those PNG files. So the scene images is just so you can see visually all the cut points. So the next thing we need to do is we've got this detection file, okay, as I mentioned. And we can't pass this to ffmpeg like this. It won't understand it. It won't be able to create clips from this file in this format, because ffmpeg, as I said, doesn't take a start and an end point. It takes a start and a duration. So what we have to do is we have to do some maths and figure out, one, how we convert this sexy decimal format to seconds so that we can subtract it, and also how we can subtract seconds if that's the format you've passed in. So we need to both be able to deal with this format and also purely seconds, and go through the file and we need to be able to take the first line and set that to be the start, and then we need to be able to take the second line and subtract it from the first line, create the duration and set that as a duration. So here's a clever thing. What we're going to do is come across the scene time. So same deal, script usage up here. I'll go through all this same thing. Basically, we got the what it does is it accepts an input file, which is going to be the cut list. We created the detection file. Okay, so what we've got down here is we've got the seconds. So what we've got here is we've got two functions, seconds and minutes. And what the seconds one does is it subtracts the second line from the first line. So basically what we're doing here is we're saying, first of all, we're specifying the print the separator is going to be a period. It's going to be 0 dot whatever for seconds format. And we're printing these formats, and what we're doing is we're actually reversing. We can actually grab two lines with awk, so we can grab the first line and we can grab the second line of the file, and then what we can do is we can subtract the second line from the first line and actually print the output separated by a comma. What it's going to do is it's going to take the second line. It's going to take the first line and set it to the duration. It's going to take the second line, subtract it from the first line, and set. It's going to take the first line and set it as a start. It's going to take the second line and subtract it from the start, which would be equal to the duration. And then what we've got here is we've got the minutes. And basically, I found some code on Stack Overflow which actually converts the sexy decimal format to seconds. And then I can do the same thing. Once it's in second format, I can subtract the lines and stuff. Now, what we're doing down here is we're using head to grab the first line of the file. And what we're going to do is run some regular expressions to check what format the file is in, whether it's in seconds or sexagesimal format. So we're basically running some checks down here to see what file format is, and basically if it's minutes, we're going to run the minutes function. If it's seconds, we're going to run the seconds function. So what I'll do is come across here, and what we need to do is run scene time -h. Okay, and that tells us we just need an input and we can set an output. The output, it is optional. You can give it an optional output name. It'll, by default, it will create a file name, the file name -cut list and the time. So if I run scene time -I, and what I need to do is give it the detection file, and that's it. So you'll see now we have this scene this detection -cut list. So what I'm going to do, come across to here and open that up. So cut list. So what you'll see is this will only output stuff in seconds, because I haven't figured out how to convert from sexagesimal to seconds, subtract the time, and then convert it back. So let me just get some more tea. So what I'm going to do is, this is the file that's created. I'll just switch back to the detection file. So you can see here, this is the detection file with all the cut points. So this is going to be the first clip from 0 to 11. The next clip is going to be from 11 to 15, and so on. So what it's done is it's taken the code that we've just outputted, and it's basically gone through and it's done all the maths, and it's separated so we got the start point here, and then we've got the duration of the clip separated by a comma. So now we've got a nice format to work with. So we've got a series of clips separated by commas. So what this allows you to do, and the advantage of using multiple scripts rather than one script, is that you can basically edit this file. If the timing's slightly off, there's the scene detection's slightly off or whatever, no problem, you can just edit the file manually. Or if you don't want to use the scene detection at all, you can create a file manually and specify the start and end point, the start and the duration for clips that you want to cut up from a file. And again, it can either be in seconds, you can either create it in seconds or sexadecimal format, hours, minutes, and seconds. And we're going to be using this file with the next script to actually chop up the video. So again, this is the format that we want, in that we've got a series of start points and durations. So now we've got that, what we can do is move on to the next script, which is the scene cut script. So what I'm going to do is, what we've got here is the detection cut list, and I'm just going to rename that to cut list. Dot text. Okay. So the files that we're going to be using are the bigbunny.mp4 and the cut list. So scene cut -h. Okay, so it requires an input file and a cut file. So let's give it those. Scene cut in bigbunny cut file, and you see it's going to start going through. So while that's going through, I'm going to go through the through this script. So again, we've got the usage, the error messages, the get ops, where we can specify the options we're passing to the script, like -i, -c for the input and the cut file. And what we do is we check if they're a file, and if they're not a file, we exit. And again, what we've got down here is the way we get the file name of the input file. And what we've got down here, right, this is the secret sauce. This is how we can take a file with a series of cut points and pass it to ffmpeg and get it to go through and chop that file up. So this is similar to what I showed you in the previous bit about one of the other scripts. We've got the count file, we've got the count, and we've got a while loop. Now this is really, really clever, this bit with the while loop. What we can do is we can set the separator to a comma. And what we're doing here is we're setting two variables, start and duration. What this is going to do is it's going to set the start variable before the comma, and it's going to set the duration variable to after the comma. So rather than in the while loop doing something like creating a variable and echoing the line and using awk to pull out the first field and the second field and that kind of thing, what we can do is we can read through that this so it's fans kicking in a bit here while it's chopping stuff up. So let me just go through desktop. Let me just get that cut file back up again. You can see here it's actually cut list. So this was the cut list. Again, we got the start, and then we got a comma, and then we got the duration. So right now, cut. Yeah, see, here we go. So what we're doing is we're going through and we're saying the separator is going to be a comma. We create two variables again. So start's going to be before the comma, and the duration variable is going to be after the comma, which is exactly what we want. Then we can run the trim video function and increment the count. So what we've got up here is this trim video function. And what we've got is first of all, we're setting the output file name, which is going to be the input file name, and then -count.mp4. So it's going to be like Big Buck Bunny -1, -2, -3. And again, this is the secret sauce. This is the thing that makes it work. Without this, it will only create one clip, and you'll be, you know, tearing your hair out trying to figure out why it's not working. You have to set that -no SDIN in the function so that ffmpeg doesn't try and read its standard input from the output of the while command. So basically what we do is we every time it's going through a line, what it's going to do is going to take each line and it's going to set the start variable to before the comma and the duration to after the comma, and it's going to pass those variables into this function in ffmpeg. So for each line we're going to get the start. We're getting the input from the -i function, -i option we used when we ran the script, but it's going to get the start and the duration from each line of that comma separated file, and then seek to the start point, and then create a clip to the for the duration. So like if you set you've got an option where it says like start 30 seconds and create a 30-second clip. It's going to go to 30 seconds, create a 30-second clip, name it Big Buck Bunny -1.mp4, and then move on to the next while line in the while loop. The fans on my computer started to slow down, so I'm guessing that means that the script is actually finished. So what you can see here is all the files that it's created, and what I'm going to do is open this in the file manager and come through. And what you'll see here is we've got the original file, Big Buck Bunny, and then we've got all these other files, Big Buck Bunny -1, 2, 3, 4, 5, 6, going on. So what we're going to do now is actually go through and have a look at these clips. So what I'm going to do is I'll open Big Buck Bunny up, which is a animation created a few years ago that's open source and not copyright, that sort of thing. So what I'm going to do is I'll just fast forward through this so you can just sort of see the sort of different cuts. So you can see when the camera changes. Yeah, so you can see all the different, basically the cut points, all the different camera changes, and then I'll go through and play all the clips so that you can see that the video has actually been cut up into those sections. So that's just me going through here. So what I'll just do now is actually come through and open these clips up, and you'll see I'll just do it quickly. But if you listen to the audio, you'll notice there's no gaps. It's not like it's one cut point and then, you know, missing frames or whatever. I'll just go through and play these, and you can see how it's cut these into individual scenes. So you can see when every time the camera angle changes, we're creating a new cut, and you know, it really depends on the threshold that you set and the type of video, you know, what kind of motion it's got. You can see we've now got all the different camera angles, all the different shots from this video. Oh, that always gets me, that bit. So you can see these this is a really good sort of example of getting it to work. Oh, that's the same clip. But if you were to join all these files up, it should be identical to the unedited video, basically. So I can come through here. See, that's the first one. We've got the second clip there. Hit. So I'm just go through and show you it's pretty accurate for this one, and it just means you don't have to crack open a video editor, import a video, create a project, chop it all up in the timeline, then sit there and export it, and then you end up with a load of project files and that sort of thing. This is a brilliant way of being able to chop up a video by analysing it, and then if needed you can tweak the time codes, or if you just want to do it manually, you got the option of creating a text file with the cut points, with the start and the duration in a comma separated file, not a vial. That's a different thing. And basically getting ffmpeg to do all the donkey work, chop your video out for you so you've got some nice series of clips. It can be perfect for things like interviews. You've got lots of, a video of lots of different interviews or whatever, and you just want to chop them up. This is perfect. You can do it automatically, or you can do it manually. So let's go through the sequence of events and how we actually got this to work, and what the process is we've got to go through. So the first thing we had to do was we had to run the scene detect script. So we ran scene detect -h to display the help, and again we've got the input file, which is the video. We've got the threshold you can set from 0.1 to 0.9, and by default it's going to go to 0.3, which is what I've been using with Big Buck Bunny there. And then we've got the timecode format that you want to output in. So you can either, by default it's going to be sexy decimal, or if you want seconds, you can specify the -f option. So basically we just ran scene detect -I, Big Buck Bunny, went with the default options, and what that did was that created the detection file in this format with the start time appended and the duration appended to this list, so that we then have the start. That's going to be at the end of the first scene and the second scene. So that's the first thing we did, was create the actual detection points. After that, what we wanted to do was actually have a visual representation of all those cut points, and the way we did that with the scene image script. And basically we just run scene image images -I, Big Buck Bunny -C, and then the detection file that we created in the previous step. And that created all the images, so that we could see visually, where all the cut points were, because just having the time codes isn't, unless you're sort of Rain Man, you're not going to be able to go, 0.1 whatever is the, Big Buck Bunny being hit with an apple or whatever. So that's why we need the images, so we can actually see where all the cut points are. Then once we've done that, the most important thing is actually taking that detection file that we created and running the scene time script, which basically takes the input, which is going to be the detection file, and you can optionally specify an output file name if you want. So So basically what we did was we run scene time -i section. Let's give it an out file, name output.text, less output.text. And as you can see here, what we've got is a comma separated list of start points and a duration for the clip in seconds. And again, you can give this scene time script either a detection list in seconds or in hours, minutes, and seconds, but it's only going to output the cut points in seconds because, as I said, I can't figure out how to convert from sexagesimal to seconds, subtract the time, and then convert it back again. But you know, it's not too much of an issue. You know, obviously, you know, 91 is going to be 1 minute 31 seconds. Yeah. So what you can do is in your video player like MPV, you can specify milliseconds output so that you can actually basically see exactly what frame this is referring to. So this basically is the format that we want, where we've got a start time, a duration separated by a comma. Again, once we've done that, the next step is to take that file and the video file, pass it to ffmpeg, and go and make a cup of tea while it chops up the video. So what we did was we ran scene detect -h for the help, and basically it tells us, no, scene cut was the one I want, sorry, scene cut -h, and basically the scene cut takes the input, which is the video, and the cut file that we just created. So we ran scene cut -i bigbunny.mp4, and I won't run the script again, but that's how we basically take that file and then get it to chop up all the clips. And let's open the file manager again. And again, what we'll have here is at the bottom we've got the detection, which was the first one we created. Then we got the you know, the cut list we created here, and basically what we did was we used that cut list, the scene cut script, and the Big Buck Bunny, and it's gone through and it's created all these files with the start point and the duration to the millisecond. So this is the advantage, is that you can actually cut to the millisecond using ffmpeg, and have, you know, the perfect clips. And you can see these are all sort of quite small clips. This is a 720 clip. Okay, this is the bit where he gets angry, but you can see how this cuts stuff up. So like every time it's, there we go, it's fade out. It's sort of faded back in. So that's how that will basically work and chop everything up. So let me just go through the scripts again. So okay, so we've got 4 scripts. The first one is the scene detect, and again, what we've got, the usage. So you display -h, or you get an error or whatever, it's going to display the usage. We've got the error messages. We check the number of arguments passed to the script. We create some regular expressions to match the input for the threshold that you specify on the command line, and also to specify to match the format, you know, if you type seconds. Then we got the get ops. So these basically all correspond to the options you pass on the command line, -i, -f, and -t for the threshold. We've got the variables here to get the input file name, specify an output file name, and set a default threshold. And then we've got the 2 functions, the seconds and the minutes. And basically what those do is, first of all, we get the duration, and then what we do is we move on to the next step, which is using ffmpeg to actually get the PTS time, which is the timestamp of the cut point. And finally, what we do is, after all that, we use awk to actually prepend the start time and the duration, and we do that using this begin function here. You can see begin at start, so that's going to print at the start of the file, and then what we have is we're printing all the rest of the file here with this -0, and then at the end we're printing the duration, which is the duration variable we got from ffmpeg, and then we save the output either with the default name or a name you specified on the command line. So that's the scene detect script again. Then we moved on to the scene image script, which is what we use to generate all the images. And again, what we've got down here is we've got this while loop. So we've got the count, which we set to 1 outside the while loop. We read each line and set the line to equal a variable of seconds. We run the extract function and we increment the count. And then up here, what we've got the extract function, we create the output file name, which is the input file name -count, so 1, 2, 3, 4, whatever. ffmpeg, remember, you have to use no st_in. Don't use that, it's not going to work, it's only going to create one file. So that's the secret source. Then we pass in the seconds variable from the while loop. So basically what will happen is ffmpeg, each line is going to take the seconds, seeks to that point in the video and create an image. So that's the scene images script. And the next one is the scene time script. And this is the script that does the maths. So let's get back down to here. So this is the seconds function again, where basically we're subtracting the second line from the first line and printing it out separated by commas. And then this is how we convert the sexadecimal to seconds and do the same thing. Then what we do is we got this timecode regular expression where we grab the first line of the file, check what format it is, and basically then at the end, depending on what format's been detected, we run the appropriate function, the minutes or the seconds function, and it's basically going to do all the donkey work, do the maths for you, take all those time codes, and basically give you a start and a duration separated by a comma. So that's the scene time, and then we've got the scene cut. And again, I'll just move to the bottom of the file, and this is the really clever bit, using 2 separate variables in a while loop with the IFS set to a comma. Basically allows us to take a kind of CSV file. Obviously we don't put in the headers because otherwise it's going to fuck up the script. So basically what we do is, as I said, we read each line, and basically anything before the comma is going to be set to start, and anything after the comma is going to be set to duration. So each line, it's going to go through and say, okay, the stuff before the comma is the start variable, and the stuff after the comma is the duration. We then run the trim video script and increment the count. And again, what we got up here is we set the output file name. Most important thing is the no st_in. And this is what's clever, is that it's basically going through line by line in that while loop, taking the start before the comma and the duration after the comma, and passing them into this function. And basically what ffmpeg does is just going to go through each line of that file and seeks to that point in the video and create a clip for the duration that's specified in the file. And basically what it's going to do is it's going to create each file with the input file name and then dash and an incremental count. So it's going to be bigbuttbunny-1.mp4-2.mp4 so on. And again, it's not. I did think of trying to pass in the seconds as a as something to stick in the file name, but the you can't actually get the seconds variable from the while loop while you're using no SDN. And the most important thing is to actually get the create all the clips for each line rather than getting the file name with the seconds. So that's why we're using a count. So basically, it's going to go through each line, find the start and the duration, seek to that point in the video, create the clip, and then move on to the next line throughout the whole thing, and just basically chop up the video. So that's ffmpeg scene detection, and also how you can manually create a cut list. So this is with the cut list that you actually pass into the scene cut script. And again, you can create this manually, either in seconds or in hours, minutes, and seconds. So you can specify, you can create a cut file, like, just switch to the scratch pad for a minute. So you could either create, I can't, let me, it's not let me. So you can either create it, in this format. So that would basically create a clip from the beginning of the video for 30 seconds, or if you wanted to do 1 minute 10 to you want to create a clip at 1 minute 10. The best way to think of this actually is if you're old enough to have used video recorders back in the day, think of it like pressing record on the video player for half an hour. So it's like basically you're saying, okay, at 1 minute 10, press record for 30 seconds. So so that's what may confuse you, is why you'd think that it would be a start point and an end point. It's not. It's a start point and a duration. So this is going to create a clip from 0 to 30 seconds. It's going to create a clip at 1 minute 10 for 30 seconds. So that would be from 1 minute 10 to 1 minute 40. So you can either create it in that format, or you can create it purely in seconds, and it just means that you can actually manually go through and adjust the cut list if needed. So if something's slightly off, you can just go through the text file and adjust the timing to get it bang on. So that's the format. That's how everything works. And again, did I have that on a separate thing? Yeah, I've got that here. And basically this is the end result. It's going to go through, chop up the video into all the sections, and let's just go through more clips so you can see. We've got all the different shots. I mean, that's pretty cool for not being able to, you don't have to use a video editor, which is an issue on Linux because all of the open source video editors are rubbish. The only good video editor that's at professional level is DaVinci Resolve, and that does require a lot of RAM, and got to run special scripts to install it and stuff. So it's not that actually easy to install, and it's not open source. It's sort of proprietary. But it's an excellent video editor, but again, it's a pain to have to crack open a video editor to do this kind of stuff when you can do it with some scripts. So that's all the scripts, and what I've done is come across to Napoleon Wilson ffmpeg script, which I'll put a link to. This is, I've added this to a collection of ffmpeg scripts that I've done a whole video series on. So you'll see here is the scene cut detection images. So here you can basically see an explanation of the script, what it does, how you use it, you know, scene detect, scene images, scene time. So that explains the formats that the scripts accept, and basically you know, how you use them and what you use them for. So that's ffmpeg scene detection, how you can analyze a video, get all the cut points, create the images, then convert the detection file into basically an edit file separated by commas, which you can then pass to the scene cut script, which will then go through and cut up that video for you while you have a nice cup of tea and some biscuits. And again, you don't have to use the auto detection stuff. You can just go straight to the scene cut script and create the file yourself, even seconds or in hours, minutes and seconds, by specifying the start and the duration of clips you want. And it's just going to go through, cut that file up for you, and sequentially name all the files. So you got basically all the bits of the video you want cut out without having to use a video editor. So that's ffmpeg scene detection, and some scripts I've written to make things a bit easier. And again, we want 4 scripts because basically we want one to do the scene detection, one to do the images, one to do the time conversion, and one to actually cut the video up. And as I said, the advantage of this is that it actually allows you to tweak the files or just manually create them yourself.